has been about polynomials and the ratio of polynomials, and these last 20-something problems is a culmination of all of that. Find the degree, leading coefficients, and the maximum number of zeros. The degree is the highest power, that would be 9. Questions? The leading coefficient of that is -1. Questions? The fundamental theorem of algebra says that if I have a polynomial of degree n, then the maximum number of zeros is n. In this case, it's 9. What is the end behavior of p to the 9th minus 4p to the 6th plus 5p to the 3rd plus 4? You have your table somewhere. We'll write this table for the last time. That this is a question that depends upon whether the degree is even or odd, and whether the coefficient is positive or negative. Okay. The table I'm about to draw won't be as nice as the one we meticulously drew last time, and it won't be as nice because this damn thing is drawing something ridiculous. Okay, so so the power is going to be I'm going to call it n, and so it's even, and this is odd, and then the coefficient is going to be either the coefficient in front. It's going to be positive or negative, and when it's even and the coefficient is positive, it looks like x squared, so it rises left and rises right, falls left and falls right if it's even and the coefficient is negative, falls left and rises right if it's positive and odd, and does the opposite if it's positive and even. And so this means that in this case, 9 is odd, the coefficient is 1, 1 is positive, and therefore this is going to do this. All right, so you'll know from your table that it falls left and rises right, and we just need to say what this means in terms of calculus. Falls left, rises right. All right. The calculus way of saying this, of course, is that if it rises to the right, that means as p tends to infinity, the function goes to infinity, right? So that means that goes to infinity as p tends to infinity. If it falls left, it means that as p tends to negative infinity, the function tends to negative infinity. And those should be the choices. So this, as p tends to minus infinity, means that you're moving to the left. As you move to the left, it should go to minus infinity. As you move to the right, it should go to plus infinity. I'll take questions there. What's the least possible degree of that polynomial? 3, because it crosses 3 times. And again, so the okay. So again, the argument goes, the great skeptic says, how do you know it's 3? And then you say, well, if it were 2, then the fundamental theorem of algebra says that the most number of zeros you could have is 2. But here we see 3. So it couldn't be 2. It could be 4, but 4 is not the smallest. Right.
You see how many times it crosses the x-axis?
Yeah, that's the number of times it crosses the x-axis by the fundamental theorem of algebra. Write an equation, any form for that quadratic equation. So again, the way that we did this one, we know it has to fit a certain form.
Y equals, what is it, a minus h squared plus k?
That is super close, right? So we're filling in this thing, right? So polynomials, this is a quadratic, and every quadratic takes the form a times x minus h squared plus k, right? Where h and k is the what?
Points on the graph.
Yeah, that's right. What special point on this graph is it called? Begins with a V?
Vertex.
The vertex. Right. So you can just look at the graph and find out what h and k are, right? And then we need one more point. So h and k will be determined just from the vertex, and then the only thing we need is a, and then you just need to investigate any other point on the graph to figure out what a is, right? What's h?
-1.
H is -1. K?
1.
Questions? Okay. So now we have y equals, and a we still don't know, times x plus 1 squared plus 4.
Yeah.
And so now the question is, how do we find a? And so you just find some other point, and I really like this one. Right. So 0, 2 seems to be on this graph. So when you plug in 0, you're supposed to get 2. And so when you do, so 2 should be equal to a times 0 plus 1 squared plus 4. And then that will let you find out what a is. So 2 is equal to a plus 4. It looks like a is -2, and that is not surprising because this parabola opens downward. So we knew that a had to be negative. If you go through this process and a was positive, and you look at a graph that's opening down, you've done something wrong. We're talking about -2 times x plus 1 squared plus 4. So I have copied this assignment to a test, and therefore, unlike tests in my math lab that I've given before, it's going to be just like a homework. So you're going to have multiple chances to do each problem and stuff like this. So this is set up so perfectly for you to really do well. Again, this space, I don't give a damn about grades, right? It is a, that's recorded. This is a space that where, yeah, this is a space where, again, we're just trying to present you with the material so that, you know, nothing's new when you arrive at your next math class. Without me, I need some tissue.
Yeah.
I know, yes. So, okay, good. So we can go ahead and put that in. So -2. Do you all want me to put this in, or should we just move on? Do you even care?
Let's move on.
Yeah. Okay, 5. We're just going to flat out ask for the vertex, the vertical intercept. I don't know. No one ever says vertical intercept. But the y-intercept, and find the coordinates of the two intercepts of the parabola and write them as a list separated with commas. And so, I know. All right, so when it's written in this form, we know that the vertex, the x-coordinate vertex, occurs at -b over 2a. And in this case, is 2. B is -12. C is 8. And so it's going to be -12 over 2 times 2, 12 over 4. The x-coordinate of the vertex is 3. We'll take that 3, plug it into F, and get the y-coordinate of the vertex, and that goes here as a point. F of 3 is the y-coordinate I need, is 2 times 3 squared minus 12 times 3 plus 8. 9, 18 minus 36 plus 8 negative 10. Vertex is 3 comma negative 10. The y-intercept is what happens when x is 0. When x is 0, that goes away, that goes away. You're left with a beautiful 8. I think they want the point 0 comma 8.
Yeah.
What's nice about this is if you put in 8, they mark it wrong, then you have another chance to put in the right answer. The x-intercepts, you got to set this thing equal to 0 and solve. We're back to factoring again. The first thing you should do is, of course, recognize that they all have 8. They all have 2 in common. This is where it becomes a pain, and I guess I had some debate about this yesterday. Where it looks like you need to use the quadratic formula. Yeah. And so then you've got x squared, so you need this to be 0, and so a is 1, b is negative 6, or c is 4. I will allow you to go ahead and just grab this thing and see where it hits the x-axis to, and just put the numbers in.
Okay.
Yeah. So if you just go to decimals, 2 decimals, I'm just worried about whether decimals is going to give you 2 decimal places, right? So let's take a look here. So we're talking about x squared minus, so we'll see whether they want the points or just the x coordinates. But it's 2x squared minus 12x plus 8. Two x squared minus 12x plus 8. Right, so, oh, great. Those 2 places. And then to 2 decimal places. You want both of those. Questions there? Six. Use the quadratic formula. Just flat out, just use it. Here we just got to check our signs super carefully, right? So here's the formula: x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And we're just plugging in super carefully. And again, this might be one of those where you may not get it on the first try. And so if that's the case, just check your answers super carefully. You only get 1 chance to take the test, but you get 5 chances per problem. Right?
So, the test?
Yeah. It's going to be just like this. Yeah.
Is the practice test due as an assignment?
It's extra credit.
Extra, okay.
It's extra credit, yeah. I have it labeled as extra credit. Negative, negative 2. Oh, let's see how this is going to be plugged in. Negative, negative 2 plus or minus the square root of b squared. This might even be factorable. Minus 4 times a times c. I think it's going to work out all over 2 times negative 1, right? So x equals 2 plus or minus the square root. We'll get the calculator out, but this is going to be a just beautiful 64 all over negative 2, which tells us that it was factorable. So this is equal to 2 plus or minus 8 over negative 2. And so here's where we start to split things up. It's either 2 plus 8 over negative 2, or it's 2 minus 8 over negative 2.
You just separate that. Oh, it says it right there, by commas.
Yep. 10 over negative 2, negative 5. 2 minus 8, negative 6 over negative 2, 3. 3 comma negative 5. Okay. So off the record, you know, they gave you one that looked like you couldn't factor, but you really could. They just want you to use the formula just to test it out. Seven. All right, so we tried to give you some word problem to intimidate you. There's some story that involves a parabola. And we're going to ask you something about the highest value, the lowest value, how far, and all this other stuff. Okay. So there's the parabola there, y equals minus 1 over 16 x squared plus 4x plus 5. A child throws a ball. X is the horizontal distance, y is the vertical distance. How high is the ball when it leaves the child's hand? So how high is it at the beginning? This is a question at the beginning. Well, at the beginning, the horizontal distance is 0. This is translated just saying plug in 0. Right? So it starts to model what happens when she throws the ball. And so that's at the beginning when x is 0. 5 units. It's in feet, so 5 feet. What's the maximum height of the ball? We are experts at that. This is just asking, what is the y coordinate of the vertex? The vertex is the highest point, and they want to know how high it is vertically. That's represented by the y coordinate. So find the vertex, and then take the y coordinate.
Real quick, I
Yeah.
totally blanked out. How again do you find the vertex?
Okay, excellent. Thank you.
Sorry, I just
So the vertex is found at negative b over 2a.
Right, gotcha.
Yeah.
Thank you.
So the only funky thing is that a is negative 1 over 16, b is 4, and c is 5, right? And so you just got to do that arithmetic. And so it's going to be negative 4 over 2 times negative 1 over 16. Right? And so that's going to be negative 4 over negative 1 over 8. And that is actually 32.
Okay.
That is the x coordinate of the vertex. And you need to take that 32, plug that in here, and then that is the answer that goes there. So then we're talking about negative 1 over 16 times 32 squared plus 4 times 32 plus 5. Whatever that number is. And then how far from the child does the ball strike the ground? So you're looking for the x distance where this thing's equal to 0. It strikes the ground when it's equal to 0. So you would say, let's set this thing equal to 0 and solve. And again, you could use the quadratic formula, or I think it seems like the answer is nice. Just use Desmos again and see where this hits the x-axis. As you know, this is going to hit the x-axis in 2 places, and so you do not want the negative value, right? You want the positive coordinate. Yeah. And so this is where, again, this doesn't model the mathematics exactly, right? Because we're getting this at 5, right? The child throws it at 5. Apparently this child is 5 feet tall, right? So they throw it, and then the mathematics says, oh, before that child threw it, it had hit the x-axis somewhere earlier, but that was before we cared, right? So we only care about afterwards. So again, if you graph this, doesn't hit the x-axis twice, but we care about it modeling this real-world situation starting at 0. And so you should only be looking on the right-hand side after the y-axis for when this hits the x-axis. Excellent, excellent, excellent. Eight. Wait, is that? Are they the same problem? They are. Okay, good. So I'll get rid of them. I'll get rid of number 8. I think they're identical.
Well, the difference is
Oh, 4 and 6, yeah. So I'll get rid of one of those. And if I don't, you can skip one. Let's just agree. Just do 7 and not 8, right? Okay. There's a polynomial. Set it equal to 0 and solve. What are the zeros, right? So this is an exercise in factoring. X cubed plus 8x squared plus 7x is equal to 0. They all have x in common. Factors of 7 that add up to 8. Plus 7 plus 1, 0, negative 7, negative 1. It's finding the zeros. We'll try to get halfway through this. Find the p-intercepts and the x-intercepts. So the p-intercepts, you set x equal to 0. The x-intercepts, you set the whole thing equal to 0, right? And solve. So the p-intercept looks like it's 60. The x-intercepts looks like 2, 6, negative 5. Plug in 0 for the p-intercept. Set the whole thing equal to 0 to get the x-intercepts. That seems a couple more. In behavior, we can talk about that, and then it gets super fun. Okay, let's end there. All right, so I'll stop the recording. I'll label this as part 1.